Hello everyone, welcome to this today's session. I am Ramesh from SNS College of Technology. In this session, we are going to discuss about the topic torsion equation, which comes under the mechanics of solids for the aerospace for the second year students here. In which before we have discussed about the simple bending equation. Following that, the torsion equation we are going to study, and it has been written like this: the simple torsion equation T by J is equal to tau by R, which is equal to C theta by L. Here, since it is torsion means you are applying a torque instead of force. We are applying a torque. How a torque is created? We are applying a force on the circular path so that it will be a circularly, it will rotate. So that the force created due to the circular object, like a shaft, it is rotated. Okay. So that how much force is acting and with respect to the radius, it will produce the torque. That is force into radius, which is equal to the torque. The unit is Newton meter. Already we know. So if the torque is applied, what happens in the stress? Then we for axial load generally, axial load means we can have a compression load as well as the tensile load. Okay. If that kind of load is applied, bending will happen. But here torque is applied, what kind of stress? Here, if it is a torque, generally the stress produced is a shear stress. First, I will just tell you what is each and every term represents. So it is the torque. That is here it is, we have to apply the maximum torque. J represents the polar amount of inertia. Tau represents the shear stress. R represents the radius. Since there is a torque, why I am giving stuff? There is a y in the bending equation, but here R, because it is a circular object only we are having, so that the torque will be produced. So the radius must be here. And C theta by L. That C is the shear modulus. Otherwise, you can use another parameter called G also. Okay. So C theta by L. The theta. So here angular deformation. When torque is applied on a shaft, it will rotate so that the deformation occurs in an angular way. Okay. So this is the shaft having the length here, and if it is rotating, so the torque applied, okay, due to the torque applied, it will rotate, there will be an angular deformation. Finally, there will be a angle. Okay, there will be a deformation in the angular way. That is the theta by here. That is the length of shaft. Okay, so like that you can use here. And what are the other things from the torsion equation we can say? One is called torsional rigidity. Torsional rigidity. Torsional rigidity. Generally, this torsional rigidity is represented by T by theta. T by theta. We know that what is rigid. If it is rigid means it does not give any amount of deformation. But the torsion means that angular deformation is very difficult to attain by giving the torque. If it is rigid means you have to give more amount of torque so that the angular deformation will be produced. Okay, so we can define that the amount of torque required to produce 1 unit of angular deformation. The amount of torque required to produce 1 unit of angular deformation. That is called the torsional rigidity. So we can consider this one, because here torque is there, here the theta is there. Okay. So from that, how to find the T by theta. You just shift it here, J goes there. So this will be equal to Cj by L. Okay. So torsion rigidity means T by theta after the definition. From the torsion equation, we can have another relation Cj by L. Okay. Then one more thing, the J represents the polar moment of inertia. Earlier we talked about the moment of inertia, that is called area moment of inertia, but this is just different polar moment of inertia. How to find the polar moment of inertia? So J, that is equal to polar moment of inertia. Polar moment of inertia is nothing but this is I, that is with respect to x axis plus I with respect to y axis. That is nothing but you have to add it. You have to add the moment of inertia about the x axis and the y axis. That's all. But for I told you that moment of inertia depends only on the cross section. Since it is the torsion equation, only the circular object comes into picture. So we have this shaft having this cross the circle as well as okay. We know that for a circular object, having diameter, okay, having diameter d, then Ixx, I told you, Ix is equal to pi d power 4 by 64, that is equal to I by 1. Okay, then what will be the polar moment of inertia? So you have to add, that means nothing but 2 times the value. So 2 times pi d power 4 by 64 is nothing but pi d power 4 by 32. That is the polar moment of inertia for the circular section. But don't worry about it. The polar moment of inertia only depends on only comes for the circular section, not on it also depends on moment of inertia. It comes for the all cross sections. But according to the torsion equation, it comes only for the circle. We can go for the right triangle or rectangle or any regular object. We can find the polar moment of inertia. Here we are going to find the polar moment of inertia for a circular object only. Okay. So this is the polar moment of inertia. So due to the torque, the stress produces the shear stress. Finally, here what would be the question can be asked. Okay. If the maximum stress for the material is given, as well as the maybe the diameter, that is a shaft can be given, a hollow shaft can be given, or circular, that is solid shaft can be given, as well as the angle of twist can be given. Okay, so for given torque as well as the shear maximum shear stress as well as the angle of twist, what will be the diameter can be asked. Okay, so we can relate this one and the first one too. Okay, we get the diameter. Okay, so we can have the diameter for this one for the first section. Then we can go for the top to the angle of twist. Okay, so consider the first one and the third one. Find the diameter. So this is the second case. So consider the first case D1 and D2. Which one is greater? Which one is the greater value will be the safest one. So greater value of the diameter is the answer. Because we have to have the safety. Okay, it should withstand the maximum stress as well as we can withstand the angle of, that is the angle of twist. Based on that, we are going to select the diameter for the particular section based on the shear stress or based on the angle of twist. So combined you have to concentrate and then get the diameter of the shaft and compare which one is the greater value. That will be the answer for the shaft for this part. Okay, but we will meet you in the next class with a different time. Thank you.